Going to be the start of the Neuroanatomy series, and if you want to download my notes that I used to make this video, I put them in the captions below. So the nervous system, let's start with that. It's basically used for detecting and transmitting and integrating information. So it's going to take the information from within the body and also from the external environment and decide how to react accordingly. And we're going to kind of get into a little more detail about what I mean by that. So let's first start with the divisions of the nervous system. So we've got two divisions of the nervous system. The first is the peripheral nervous system, or the PNS, and the second is the CNS, which is the central nervous system. And these both are considered the functional component of the nervous system. And so if we look at the PNS, it's made up of ganglia plus nerves. And then if we're asked what makes up the CNS, that's the brain plus the spinal cord. And then from there we know that the PNS is actually broken up. It's further broken up into the autonomic nervous system and the somatic nervous system. And so when we think of the autonomic versus the somatic nervous system, what we're really trying to say is the autonomic nervous system, because it has the word A, it's kind of automatic, right? And I always remember it as the automatic nervous system, because this one is going to control your heart. It's going to control the heart, the smooth muscle, and the endocrine glands. While the somatic nervous system is going to control skeletal muscles. And then we can further divide the autonomic nervous system. And so the autonomic nervous system can further go into the sympathetic and the parasympathetic. And you might remember that the sympathetic is the fight or flight, while the parasympathetic is the rest and relax. So what that basically means is, in fight or flight, it's the nervous system's response to a dangerous situation. So, kind of as it sounds, imagine you're about to get in a fight with somebody. Well, this guy is bigger than you, he's picking on you. So what's going to happen physiologically is your blood is going to rush to your muscles, and you're going to have a rush of energy because now your heart's pumping, your brain's working really fast, and it's trying to compensate for the fact that, you know, the guy's about to swing. The parasympathetic, on the other hand, is the exact opposite. It's the time where your body's just sending all the blood to the organs and saying, hey, it's time for me to relax, it's time to chill, nothing to worry about. So those are the two divisions under there. Like is the one that's involuntary, while the somatic is voluntary. And the reasoning is, much as this sounds, when we're looking at the sympathetic, parasympathetic, this is all stuff that we don't actually control. It's all controlled for us by the body. So the body is going to decide how to respond in a situation where we're being attacked, or after we've had Thanksgiving dinner, how do we respond to the fact that, you know, we just ate a big meal and now we're tired. So this is all under the autonomic control. Well, the somatic control is, you know, you going to the gym, lifting weights. That's going to be you controlling those muscles you're working out on. So that's the big difference between these two. And if we were to think of an issue, so if we're looking at the somatic nervous system and we were to think of something that could potentially happen, let's give the example of a neuropathy. So a neuropathy is any time that you have a disease involving degeneration of peripheral nerves. So an example of a neuropathy that's happening in your CNS is going to be something called Ulnar Neuropathy. And so an ulnar neuropathy is something that you've probably felt at least once in your life. Sometimes when you're putting your hand on your steering wheel and you're resting it like this almost, you're putting a lot of pressure on the ulnar nerve. And as a result, you're going to feel tingling in your hand or kind of down your wrist. And that would be an example of an ulnar neuropathy. So let's go into a little bit more on your CNS versus your PNS. So in your CNS, we're going to have, so your CNS is going to have gray and white matter. And so your gray matter is going to be on the outer portions. So this is going to be on the outside for the cerebrum and the cerebellum. And this is going to be because it's called gray matter because it's going to have numerous cell bodies, and it's relatively few myelinated axons. And so we're going to get into what myelination is in the neuron video. But basically what myelin is, it's this fatty coating that surrounds the neuron, or the axon itself, and that's going to allow for higher conductance. But the gray matter doesn't really contain that much of the myelin sheets, while the white body is going to be myelinated. And so the myelin, or the white matter is going to mainly be on the inner portions of the cerebrum and cerebellum. So you kind of think about it, if the gray matter is what you see whenever you dissect a brain, you see this big gray exterior, just remember that's gray matter. Now if we were to cut open a brain, the center we're going to see that's white, just remember that's the myelinated axon. And then inside the white matter they have this fancy word, just remember fascicles. And those are the tracks. They're bundles of axons that course together. And that is basically it for this lecture, or this video, I'm sorry. If you have any questions or comments, please leave them below. Also, if you like the video, hit the thumbs up, and please subscribe to the channel.